Good morning, grade 9. Welcome to your third lesson of this first week of distance learning. If you haven't already, you should have completed the lesson about gravity and motion in space. You then should have spent the equivalent of a lesson working on your poster, which you should have uploaded to ManageBack. And now this is the third lesson of the week. You're going to do a little bit of practical activity in your home. You might not have exactly the equipment that I'm suggesting here, so you might have to be a little bit creative. Okay, so items that you are going to need for today's lesson. You need a mass. I'll explain in a second. You need a ruler or a tape measure, and you need a balance or a weighing scale. Okay, now your masses are going to depend upon how big your rulers and tape measures are. Okay, it could be something like a bag of sugar, a bag of flour, something from the kitchen, something that's easy to pick up, not an open bag of sugar because you'll spill it all over the floor. Okay, it's something that is big enough that you can measure the mass of it and small enough so that you can lift it. Okay, so nothing valuable, nothing glass or breakable, or your TV or something that you break. You then will need a tape measure. Okay, it could be one like the image here. You could use a normal ruler. Okay, you might have one of these from a sewing kit or something, a different type of tape measure. All right, so you need something that can measure. And you need some kind of balance or weighing scale. Could be scales that you use in the bathroom to weigh the size of a person. Could be scales that you use in the kitchen that you would use for cooking. Try and match the masses that you're going to use to the scale that you have. Okay, so if you're going to be using your bathroom scales that normally weigh people, you need a little bit of a bigger mass, okay, minimum 1 kilo, I would say. However, if you're going to be using your kitchen scales, you're not going to be weighing a person, okay, so make sure that you choose things that will match with each other. Okay, so pause the recording now, go and make sure that you have all of those things. So today's title, how do height and distance moved affect energy? Okay, our lesson objectives for today, we're going to derive, that means figure out some equations for work done and gravitational potential energy. Okay, and then we're going to practice some calculations for work done and gravitational potential energy. Some of the lesson work you will be putting into your books, okay, and then some of it on Microsoft Forms that you can find in Teams will be a quiz, and you will practice answering some questions. Remember that I can see when you have looked at that, I can see when you have completed that. If you're following our schedule, lesson 3 will be on Thursday, and the deadline for uploading that work is Thursday, so you'll need to do the questions straight away to make sure that you meet that deadline. Okay? Pause the video, make sure you've written that down, please. Okay. I'm just going to hand over to GCSE Science Physics, all right, and we're just going to watch a little video about work done.
Hi and welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to describe what's meant by work done. You should then be able to calculate work done by a force acting on an object. Now, the idea of work done can seem a little bit tricky, but it's not as difficult as it looks. Let's start by looking at the definition. Work is done whenever energy is transferred from one store to another. Now, we normally see this happening in two different cases. Mechanical work involves using a force to move an object, and we're going to be looking at that in this video. Electrical work involves a current transferring energy, and we'll be seeing that in a later topic. In this video, we're looking at mechanical work, so let's start by looking at an example. This shows a dog pulling a sledge. Now, the dog's applying a force to the sledge, and that force is causing the sledge to move along the ground. So if we look at the energy transfers taking place, we can see that the chemical energy stored in the dog is being transferred to the kinetic energy stored in the moving sledge. However, the force of friction is now acting between the sledge and the ground. So some of the kinetic energy stored is transferred to the thermal energy stored in the sledge runners and in the ground. So as you can see, we've got energy transfers taking place here between different stores, and that means that work is being done. Looking at this example, we can see that the dog is applying a force of 50 newtons, and the sledge is moving a distance of 3 meters. So how do we calculate the work done? Well, we use this equation. Work done in joules equals the force in newtons multiplied by the distance in meters. Now, we're going to be seeing this equation in more detail when we look at forces in later videos. I should point out that you need to learn this equation. It's not given in the exam. So the force is 50 newtons and the distance is 3 meters. Multiplying these numbers gives us a total work done of 150 joules. This tells us that a total of 150 joules of energy was transferred from the chemical energy stored in the dog to the kinetic energy stored in the sledge and the thermal energy stored of the sledge runners under the ground. So can you see that work done is actually a fairly straightforward idea? Let's look at another example. This shows a car travelling at 20 meters per second. The driver applies the brakes and the car comes to a stop. We're going to calculate the work done here, but first we need to look at what happens when a car brakes. Now remember that a car that's moving has a kinetic energy stored, just like any moving object. So when the driver presses on the brakes, the brake presses against the wheel of the car. This creates friction between the brake and the wheel. At this point, the kinetic energy stored of the car is transferred to the thermal energy stored in the brakes. That means that the temperature of the brakes increases, and the car slows down and stops. So we've transferred energy from the kinetic energy stored of the car to the thermal energy stored of the brakes. That means that we've done work. Take a look at this question. During braking, a force of 2,000 newtons is applied to the brakes of a car. The car takes 20 meters to come to a stop. Calculate the work done. Pause the video and try this question yourself. Okay, here's the equation that you need. Work done equals the force multiplied by the distance. In this case, the force is 2,000 newtons and the distance is 20 meters. Multiplying 2,000 by 20 gives us a work done of 40,000 joules, and that's our final answer. Remember, you'll find plenty more questions on calculating work done in my revision workbook, and you can get that by clicking on the link above.
Okay, so it's not too complex an idea, really. When a force acts upon an object, then energy is transferred, and that transfer of energy is known as work done. Okay, so the two things that affect how much work is done in these situations here, okay, is going to be the mass of whatever the object is, and therefore the force that it's applying, and then it's going to be the distance that they have to move. Obviously, to push that boulder further up the hill, more energy is going to be required, so more work is going to be done. If you didn't already pause the video to write down the equation, can you do so now, please? So when a force causes a body or object to move through a distance, energy is transferred and work is done. And the equation is work done equals force times distance moved. Work done is in joules, the force applied is in newtons, and the distance is in meters, okay? A shortened version would be WD equals F times D. Okay, now on to your bit of practical activity. Okay, you are going to firstly select an object. You are going to use a balance to measure its mass. Then you are going to calculate the object's weight force. Remembering we have done this equation before, all right, remembering that weight equals mass times gravity. W equals mg. Okay, so you should know the force of gravity on Earth so you can calculate the weight. You are going to measure your height, all right, from the floor to shoulder level. So hopefully you have a decent tape measure. You're going to place the object on the floor and then lift it up to your shoulder height and then put it back on the floor 10 times as fast as you can. Okay, so the object is going to start from here. You're going to lift it up, put it back down, lift it up, down, and you're going to do that 10 times. Okay, you repeat until all your objects have been tested. Be good to do maybe a minimum of 5 different objects. Okay, get you a bit of a workout as well as a physics lesson. So this is what you would do. You will copy this table. You'll use a pencil and a ruler to write this table in your book before you start your experiment. Okay, you are going to write down the mass of your first object, if it's a bag of sugar, if it's a water bottle, whatever that is. Okay, then you are going to calculate the weight. Okay, so from the mass to the weight, you should know how to do that, but you need to multiply by the force of gravity. Then you're going to write down your shoulder height, converting that into meters. Okay, I'm pretty sure all of you will be 1 point something meters. Okay, some of you more than others. Then you are going to calculate the work done for one lift. So the force, okay, the force that you've calculated, multiplied by the distance, which is your shoulder height, okay? Then you are going to multiply that by 10 to get it for 10 lifts. Okay, so I want you to do that for 1, 2, 3, 4, 5 different objects, please. Don't injure yourself, okay? All right, next concept that we're going to look at today, so you've just had practice calculating work done. The next concept is going to be about gravitational potential energy. So when you lifted those objects from the floor to shoulder height, okay, the work that you did was then transferred to the object. So the object then had more gravitational potential energy. Okay, again, when you're watching this video, can you make sure that you pause and write down the equations and make sure you do any examples that come up.
Hi and welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to calculate the amount of gravitational potential energy gained by an object raised above ground level. So we're going to start by looking at what's meant by gravitational potential energy. Gravitational potential energy is the energy stored in an object due to its position above the Earth's surface, and this is due to the force of gravity acting on an object. We're going to start by looking at a simple example. This shows a ball sitting on the ground. I'm now going to lift the ball off the ground and place it on a shelf like this. To do this, I'm using the chemical energy stored in my muscles, and I'm changing this to gravitational potential energy in the ball. So the ball now has a store of gravitational potential energy. If I now allow the ball to fall off the shelf back to the ground like this, then the store of gravitational potential energy is now changed to other forms of energy, such as thermal energy and kinetic energy. So the ball now has no gravitational potential energy. We can calculate the gravitational potential energy of an object by using this equation. The gravitational potential energy in joules equals the mass in kilograms multiplied by the gravitational field strength multiplied by the height in meters. The gravitational field strength is a measure of the force of gravity, and this value will be given in the question. Now, you are not given the equation for gravitational potential energy in the exam. You've got to make sure that you learn it. Okay, let's take a look at a sample question. A crane lifts a 75 kilogram mass a height of 8 meters. Calculate the gravitational potential energy gained by the mass. The value of the gravitational field strength is 9.8 newtons per kilogram. So, here's the equation that we're going to use. The mass of the object is 75 kilograms. The gravitational field strength is 9.8 newtons per kilogram, and the height is 8 meters. Putting these numbers into the equation gives us a gravitational potential energy of 5,880 joules. Here's a question for you to try. A ball with a mass of 500 grams is lifted onto a shelf which is 1.5 meters above the ground. Calculate the gravitational potential energy gained by the ball. Pause the video now and try this yourself. Okay, here's the equation that we're using. The mass is 500 grams, so first we've got to convert this to kilograms by dividing by 1000. 500 grams is 0.5 kilograms. The value of the gravitational field strength is 9.8 newtons per kilogram, and the height is 1.5 meters. Putting these numbers into the equation gives us a value for the gravitational potential energy of 7.35 joules. Remember, you'll find plenty more questions on gravitational potential energy in my revision workbook, and you can get that by clicking on the link above. Okay, so hopefully now you should be able to calculate the amount of gravitational potential energy gained by an object raised above ground level.
Okay, so I hope that you managed to do the example question that was in the video. Now I want you to go to Microsoft Teams, please, and there is a quiz there for you to complete. Remember, it should be marked automatically. Make sure you don't make any typos. Things like putting O instead of 0 would mean that if there was a number for your answer, it would come up incorrectly, so be careful with that, please. And once you submit it, I will be able to see your answers. Okay, thank you. So this is the last thing that you'll need to do for the first week of distance learning. Please let me know if you have any questions. Bye-bye.